tested, everything was same. Only thing is that I said, like normally what everybody does. Restart. I restarted because configuration wise, they are in different templates, device template, then it is we can understand that maybe we have done something wrong. But when I'm putting the configuration, when I'm putting both the device, New York and Dubai, in the same device template, same way DC1 and DC2, they're in the same device template. They're getting the IP address, system IP, everything is changed. If you see now the templates devices, we say them all. They're basically we manage. Their system IPs have changed. And now let us see now. Go to the network. Let's go to now New York. Go to troubleshooting. Let's simulate flows now. This time I say I want to go to, let's say, VPN 100. I say in VPN 100 I want to go to 192.160, that is Dubai. And now it shows, see, now it is showing MPLS. See, it is showing MPLS now, because internet I kept before I went, my internet router I had kept it down, right? So internet is down actually. Now again, let us bring up the internet again back. Interface range E0/0-3 no shut 1/0-3 no shut. Again I make the interface again up, so internet router has come back again. All these interfaces have come up, line protocols have come up. Now they will again establish. Simulate flows again. Let's say VPN 100. I select the same interface, destination, same destination. And now you see it is showing both MPLS as well as business internet, because there was nothing wrong basically. We did not do anything different. If 4 devices, they were in 4 different device templates. While applying the feature template, if I had done some mistake, then that could be understood. But when we see that DC1 and DC2, they are in the same device template. New York and Dubai, we had put them in the same device template. That's the scalability. So since we are going for lunch, that's the only thing I did basically. I said, let me stop the lab. So sometimes this lab is behaving sometimes strange, weird. I think some next office, they're doing some drilling work. Okay. Same thing now. Let's say I say New York. I want to go to now. Let's say DC. We will go to now data center. I say I want to go to data center destination. Data center destination is 12.12, and we should see now 4 path now. Still, why DC1 is still not coming? DC1 MPLS has not still come up. See, it is showing MPLS. Using MPLS, it can go through DC also. Using MPLS, it can go through DC2 also. Internet, it's not going. Or the interfaces on the internet router. Show IP interface brief. 180, this is up, this is also up. DC1 is ping again destination IP. Let's say let me ping 180.10.22.151. It is in VPN 0. I say let me see, I want to use internet. DC2 5 packets transmitted 0. Success is 0. Why DC2 problem? DC1 is problem again still. DC1 180. We had kept shut down. I think somebody said we'll keep it shut down. Show run VPN 0 interface gigabit 0/0. See, it is shut down. Yes. So we need to go back. Inter VPN 0 interface gigabit 0/0. No shutdown. Commit. It is telling right now. See, it is this device is being managed by the vManage. So configuration through the CLI it is telling not allowed. So now we cannot do this once it is become part of the fabric. Once it is managed by vManage, then the device we cannot configure it through CLI. So I need to go back to call vManage. In vManage, basically, I go to devices, DC1. This is the DC1 device. Change device values. It will take me to this template. IP address looks good. 180.10.22.151. Ten 122 gigabit 0/192.162.22.151. Let us push the template again. Success. If it is success, I say show me the configuration DC1. Show me the running config. Interface VPN 0 gigabit 0/0. No shutdown. Now it is showing no shutdown. So here it is good. How about this side?
Today it became the troubleshooting class, sir. More than.
Yeah, good, but it was a good learning experience, right?
Yes.
So interface is up now. But actually, you see, we did not do anything, for in troubleshooting. What we did, we just did the comparison. We checked this thing because configuration wise, I did not find any mistakes basically. Thing was that yes, that controllers they did not had that static routes. for reachability. So that we established, of course, that was part, because routing, ultimately it is all related to routing.
Yes. Though it's not fault, but at least we can go
yeah,
and
we can, because so underlay, once we establish the underlay correctly, then in the BGP also, once I redistributed, connected, everybody, all the components got reachability to each other. So now DC is again up. So if DC is up, let's say again one more time, we go to network section. This time again I go to, let's say, New York. New York was the guy who was creating problem. Let's say troubleshooting. I say simulate flows. Let's select VPN 100, interface this. Let's say data center. And now we should see 4 path. And there you see, this is what I wanted the output to come. 2 path business internet, 2 path MPLS. Why? Because in data center you have basically 2 devices, 2 VH. 151 basically is DC1, 152 DC. So every device now, any device, any user going towards data center, it will always have what? 4 path. Why 4 path? Because you have 2 WAN service. Since you have 2 WAN service, from there you get 2 path. And then from each WAN service, basically in the data center, there are 2 WAN edges, which are advertising the same route. And that's the reason this becomes what? Equal cost multipath. All the 4 paths will be utilized by default. This is the default behavior of Cisco Viptela SD-WAN fabric. If we add one more service, it will show one more service here, WAN service. All the paths will be used, even though they might be bandwidth wise, they might be unequal. Okay, but as far as the fabric is concerned, all the links are treated equally. This happens same like what we have basically, in case of this architecture, actually, they copied from basically the data center environment. In data center also, what we have basically, like this basically. If you see basically, if I write here VH1, VH2, we have basically VH3, like this. You have one WAN service, you have other WAN service, basically internet. So if you see WAN like that, if any WAN edge wants to go to any other WAN edge, it can use this service also, it can use this service also. This is same like basically in the data center, they have basically 2-layer architecture. This is called as what? Spine and leaf architecture of the data center. The WAN edges here are looking like basically, like the leaf switches, and this cloud, basically this internet clouds are basically like this spine switches, like that. This looks like that, equal cost multipath. So over there also layer 3 is there basically, and because of that, whatever the routing protocol, it will show all equal costs basically, like that.
Sir, sir, in our data center, let's say we have full control, we are putting equal bandwidth interfaces connected between the leaf and spine. Sir, in the WAN, let's say that I want to prioritize, my internet over the MPLS.
Yes.
So I want more traffic to be going through this one. So load balancing some kind of.
So that is where, if you refer to my blueprint, we have route preference. Lab is there now. We'll be doing that.
Route preference. Okay.
Yeah, we'll be doing that. We will like to prefer. We'll have some of our own policy that no, if the traffic is from this, location going towards maybe a certain location, I want the traffic to go via internet, maybe not via MPLS. So we'll do that manipulations.
Okay.
Yeah, don't worry. Yeah, we'll be doing that because that lab is there already in the blueprint. If you see course blueprint, I already mentioned the route preference, and that is the reason basically in the data center. I have kept basically the site ID not same. For DC1, I kept the site ID 1221. And for DC2, I purposely kept a different site ID 1222, like that. That is the reason, so that later on I can show you some, route manipulation, traffic manipulation. Okay.
Yes, sir.
Yeah, so that's the reason I've designed this lab, the site IDs and all. On purpose, I have designed some things so that I will be able to demonstrate to the students, various requirements. Okay, clean up this. Now, one thing is there basically, okay. Certain terminology we need to understand before we jump into the next thing. You see here in this thing, what information do you see here? On whenever we do this simulate flare, what information do we see here? We see one information, this IP, we see destination IP, right? Like that. Then we see what? The encapsulation. And the third one, we see the WAN service name. This is called as what? Color, correct?
Yes.
This is called as, this IP is what? System IP, it is already written here. And encapsulation is what? IPsec. These three things together, okay? These three things together, color, system IP, and encapsulation, and this thing, these three things together, this color plus, I'm just writing down this one, system IP plus encapsulation, these three things together is known as what? T-lock. This together, it is called as what? Transport locator, T-lock. It is called as what? T-lock, transport locator. Transport, this T-lock is like what? In our traditional WAN, this transport is what? Like next hop or gateway for a particular destination, like that. So this is one term in Cisco Viptel SD-WAN, which is called as what? T-lock, like that. Now see what happens basically. Okay. In this Viptela SD-WAN fabric, every device is known by what? Is known by which IP?
System ID.
System IP. Why system IP? It's known because if you see now, let me draw here itself now. You can have basically, see, let's say here is my vManage or vSmart, any one controller. If one controller is good enough, like that, you have here vEdge. Let's say some vEdge1 is there, like this. It is connected to this cloud, let's say internet cloud. It is also connected to this vManage, is also connected. So it has what? I'm just writing, let's say system IP SI. It has this system IP, right? This is its physical IP. This is gigabit 0/0 IP, like that. So when it is advertising this, vManage is recognizing the WAN edges by what? Their system IP. vSmart, or let's say vSmart is also there. This is vManage or vSmart. It is recognizing them by what? By their system IP. Sorry. So all the devices basically they write. Why? Because tomorrow, if I have basically another WAN service means what? Another interface, like that, possibly, like that. Or it could be same thing. Oh, this could be another IP. So if you see, IPs can keep on changing. Like in OSPF, how the routers, or in BGP, in iBGP normally, what type of pairing we do? Loopback pairing we do. Why we do loopback pairing in BGP, iBGP?
Because the physical interface down, we will lose the connectivity.
Because if we use it, if you do physical IP pairing, if the link goes down, then BGP neighborship will get reset, right? Neighborship will be lost. Neighborship will get affected. So we want that, since there will be always multiple paths, So we take the benefit of what? Multiple path reachability. And that's the reason in iBGP we usually configure BGP peering using what? Loopbacks. Like that. So same way over here also, if you see now, in case of this we manage, sorry, we will not be SD-WAN fabric here. The devices basically they are known by what? Their system IP. Like that. Okay. Now, see what is happening basically. See, suppose as I said in VPN, there is a network X. In VPN, this network is where? In VPN 100. Let us take example. I'm just writing VPN 100. So we have network X in VPN 100. Now when this VH1 is basically advertising this route to vSmart, he is going to send this route to vSmart. Suppose it is sending through internet cloud. This WAN service it is sending, let's say. Okay, it is sending, let me use a different color. Is sending this information to vSmart through OMP. It is sending what? It is saying, yes, I have this network X. This network X is basically part of this VPN 100. Okay. And then it has to send what? Via. So in the via, what IP it is sending? In the via, it is not sending IP address of its gigabit 0/0. It is sending what? Via TLOC. And in TLOC, what is one of the component of TLOC is what? System IP. Like that. It is sending like this TLOC. It is telling, VH1 is telling vSmart, hey vSmart, I have this network X. It is in service VPN 100 and it is available via my TLOC, like that. And in TLOC, what information is it giving? Is telling that this is basically my system IP. And then for this network X, anybody wants to send the data, it has to be encapsulated in IPsec. And now the WAN service here, see this TLOC, when it is sending on this link, it will be sending what? It has internet connection. So internet connection means color is 1. So that means now when you have second WAN service, each WAN edge now will have how many TLOCs? If you see each WAN edge has two TLOCs. See, if you see 151 here and 151 here also. This is MPLS and this is, so basically every WAN device, when you have multiple WAN service, multiple WAN transport, the colors will be different. Since the colors are different, ultimately the TLOC, there will be two different TLOCs. It will say it is available via TLOC 1, and same thing when it is advertising here, it is going to advertise basically, via, it will say X via basically TLOC 2. I'm just writing TL2. Why? Because in this TLOC 2, the color will be what? MPLS. System IP will remain same. Encapsulation has to be there. It says no. Security is paramount. Like that. Any data, if somebody is sending me any data, I don't want that data to come clear text. So for my network X, the data always has to come encapsulated, because this is the promise. Viptela promise to the customer that their customer data will be secured at all times. So this is called as what? TLOC, transport locator. Like that. Transport locator is like what? Next stop. So whenever managers are advertising the vSmart to the vSmart, they are sending this information where it is visible. Let us go and see this. I go to the network. We select vSmart. We go to a real time. And if I type here basically OMP, see we were checking earlier OMP routes. And now you see here, you have basically OMP received TLOCs. So let us see now which TLOCs they have advertised. So see, this is the system IP. First one, let us take this example. See, this is basically DC1, and this is the color, and this is the IPsec, like that. Okay, and you see by default, when we say encapsulation, what is basically going to have use? See, basically it is for authentication, it is going to use SHA-1 HMAC, and for encryption, it is going to use AES 256 by default. This is the SPI, basically it is assigned some number, TLOC SPI number 256. That. And it is telling this is its IP, and now it is showing, see, it is showing its real IP. So actual IPs are here. So 2 T-locks, if DC1 advertised to be smart, 2 T-locks. DC1, these are the 2 T-locks. DC2, these are the 2 T-locks. New York, 2 T-locks. Dubai, 2 T-locks. LA, why it is showing only 1 T-lock? Because LA1 has only one WAN connection, business internet. So as we add the WAN service, what is happening? They advertise that information to the vSmart, that they're telling that, okay, I'm available, my this system IP is available via MPLS also connection, and I'm also available via this also, like this. So this T-lock, it is advertising basically. Okay, so when now let's say another WAN edge is there. Let me put up another WAN edge. Let's say we have another WAN edge here. VH2. He has also connections basically maybe like this. Okay, so now vSmart, he also has VPN. This guy also has some VPN 100. So vSmart received this network X. Now vSmart is going to advertise this to this guy. So he's sending him. He's sending like this. He's telling, hey VH2. Since you have VPN 100, I'm sending you one route of VPN 100. This I'm giving you this network X. It is basically part of VPN 100, and it is available via TLock 1, and it is also available via TLock 2. Like that. Now in this basically TLock 1 and TLock 2, what is their IP? It is a system IP. Now the question is what VH will say. This VH manage is accepting this route, but he is going to ask now, okay, vSmart, you are telling that, okay, this is the net, this is the destination, this is the network X. Okay, I can reach via this gateway. This is the IP. But in this IP, the IP is actually what? It's like a router ID. Now the question is, how do I know this IP? How do I reach this IP? How do I reach this IP? And this is where this received T-locks is information is there. This is where you see this is the IP of DC1, or let's say this is the IP of, let's say VH1 is like New York. If I say New York, it says okay, this is T-lock1, TL1, and let's say this is TL2. So if this is TL1, over here you see it is telling that, okay, this TL1 basically it is reachable via my physical IP. This is my physical IP, and underlay everybody knows this IP. And same way MPLS, everybody knows the MPLS IP. All the WAN edges, they know the physical, because underlay has to be earlier up only. So they know. So basically, how many normally how many types of routes we have basically? Okay, we have basically in now SD, we tell SD-WAN how many types of routes we have basically. We have basically service VPN routes. We have service VPN routes, right? Then the service VPN routes, if they get redistributed transported, we have basically OMP routes. So OMP basically has to advertise this service VPN routes. Then OMP also has to basically it will receive this. It has to advertise what? The T-locks. What are the T-locks? Everybody must know about every other T-lock. So it advertises this T-locks, and then OMP also has to now, since it advertises the T-locks, it must also tell every client, every WAN edge that, okay, this T-locks basically is reachable via how this T-locks will be reachable. So this is called as what? T-lock routes. That is what I did this command, OMP received T-locks. So basically OMP has to advertise how many types of route? Service routes it has to advertise. It also, its job is to also advertise the T-locks, who is every WAN edge it has to every WAN edge has to advertise, yes, I am so and so. And then third one is what? How that particular T-lock will be reachable. So through it's basically real physical IP. So if there is one TLOG, it will show what is the real physical IP for that particular TLOG reachable. If you have second WAN service, then basically the same TLOG but different color, you will have second TLOG basically. So three types of routes OMP has to basically manage. Normal service VPN routes, it has to advertise, but service VPN route gateway will be what? TLOG. So it has to also advertise TLOG information, and then how to reach those TLOGs, it has to advertise the TLOG routes. And that's the reason when we say here OMP, basically when I say OMP, you see basically OMP is advertising. When we say routes, basically when I say OMP received routes or OMP advertised routes, these are basically what? What are these basically? These are the service VPN routes. These are basically what? Service VPN routes. And then basically you see OMP received TLOGs and OMP advertised TLOGs. Basically this means what? The TLOGs and the TLOG routes together, because it's not showing them separately. So when I say, see now vSmart is going to advertise the TLOGs. So what are the TLOGs it is advertising? See, it is advertising this TLOGs. It is telling this is one, this three combination is called as what? One TLOG. He is advertising to whom? He is advertising to DC2. Then is advertising. Okay, let me, but I need to write now, clear this. This is, see, you see this so many times, you see all this is what? Same, one TLOG only, because this is the IP. IP is same. But if you see here, color is what? Different basically. So you up to here you have what? Color is MPLS. So this is basically, this is one TLOG. This is one TLOG of whom? This is basically, let's say this is TLOG 1 of DC1 TLOG 1. This is basically, and then you see this is basically TLOG 2 of DC1. Now it is advertising to whom? So if you see now, this thing it is advertising to is giving to whom? Is giving to DC2, New York, Dubai, and LA. See, same thing again is advertising back again. Same thing here also. It's telling, okay, hey guys, this data center one has two TLOGs. So it's advertising the first TLOG also to everybody like that. Same thing. Now this becomes what? DC2. This is basically TLOG 1. Sorry, TLOG 1 of data center 2. This will be TLOG 2 of data center 2. Again, he is advertising to whom? He is advertising to the same bunch. Now this time you can't have here, this is DC2. So in this list, to peer, you can't have here DC2. So here in this case, he is advertising to DC1, LA, New York, and Dubai, like that. See, like that. And if we go down, same thing for all. So every, so this is basically, see, it is advertising the TLOGs and how it is reachable. Also, it is showing TLOG route. Also, it is showing it is reachable via this public IP. See, it's telling, hey guys, please note down. This guy is reachable via this public IP. See, if I go bring it up, it is telling this one, the TLOG 1 of data center is reachable via, since the color is what? What was the color here? The color is MPLS. So see, it is showing it is reachable via 10.122.151. This is the DC1 IP address. And the second TLOG, it is the color, the WAN service is internet. So it is showing it is reachable via this 180 IPC, 180.10.22. Like that. So this is called as what? This is called as TLOG, and this is called as what? TLOG routes. Everybody must know how to reach a particular destination, because everybody is going to recognize everyone by their system IP. So, but the system IP is what? Virtual IP. So it's like a router ID. How do I reach that router ID? Via the physical IP. This is the underlay kind of. And the system IP is the overlay IP for every WAN, every WAN edge. So OMP's responsibility is what? Not only to advertise the service VPN routes, it has to also advertise what? The TLOG. Why it is like that? Because now, again, let me clean up. Again, I say OMP. Now let us see OMP advertise routes. So if vSmart is advertising some route, let us filter only for VPN 100. I say show me only for VPN 100. Let's see for VPN 100. So it is actually, it is advertising this prefix. Let's say it is advertising some prefix 10.0. This one, to whom it is advertising, is advertising to this peer. This is DC1. See, he knows them. He knows he's sending this to DC1. He's sending this to DC2. Like that. DC1 is sending some prefixes. Then DC2 is sending some prefix. Again, is sending some prefix to DC1. Like that. So DC1 is sending all these prefixes. And if you see here, see the TLOG IP it is showing. It's not showing next of the physical IP. In this, if you see, it's not showing the next of physical IP. Nowhere you see here. Nowhere you see the physical IP. This is like same like, you know, like in BGP basically. To make you understand this. Let me clean up this again. Let's say we have BGP. We have basically routers here. Let's say we have 3 routers. This is IBGP. Suppose I have network A here. Sorry, network X is here. If this router B receives this network X, if router B, first of all, what will be the peering? Let's say the IP here. Let's say the IP here is, let's say IP here is A, and IP here is, let's say B, and let's say the IP here is, let's say D, and let's say this physical IP is, let's say C. Okay, so I'm not writing the IP address. I'm just please try to understand. This is IP A, IP B. They will be in the same subnet. C and D will be in the same subnet. But okay, network A, X is there like that. Network A receives this router B in BGP receives this X. So if I do now show IP route on router B, this is on router B. If I'm doing, it will tell me like network X is available, right? X is available via what? It will show. What will be the IP address here? Via
A.
No, it will not show A, because in IBGP you don't do peering using the physical IP.
Yes, IBGP.
There will be basically, let's say, some loopback 0, right?
Yes.
So it will show via what? Loopback 0. It will show. It will show the neighbor IP. Not the next of will be not the physical IP, right? In the BGP table, it will always show the neighbor IP. Like example, we did BGP, and that's the reason in the routing table there has to be what? Underlay has to be there for IBGP. Underlay will be like, let's say, OSPF. So OSPF will show that this loopback 0 of A is available via A. So this is called as what? In our traditional WAN, we call this as what? Recursive lookup. To go to a particular destination, BGP says go via this IP, but this IP is not directly connected. That's the reason there is no outgoing interface. So the router scans again. It says, okay, how do I go to loopback 0? Loopback 0, I go via A, and via A is available via interface. It will say outgoing. Let's say this interface is basically E0. So it will show that via E0 interface, because outgoing interface has to be there. Because outgoing interface, if you don't get, then you cannot create the layer 2 header. Clear, guys? So in our traditional WAN also, in case of BGP, in case of IBGP, this is what happened, because in IBGP, we always do peering using what? Loopbacks. And in the routing table, network X will never be seen via A directly, like that. That's the reason Cisco router, they do what? Ceph. So over here also it is the same thing, like that. When he's advertising this network, when we say advertise routes here, this particular, suppose we take example, one particular route. Let's take, this is the Dubai route 44. Dubai route, it is advertising to data center DC1. When it is advertising this route to DC1, okay, is sending basically next, is telling TLOC, this is telling this is reachable via 10.1.144, the system IP of what? Dubai. But now the problem will be what? If the DC1 does not know how to reach this one, then this thing will not work basically. Then this route will become what? Unreachable. And that's the reason OMP advertises what? OMP also advertises the TLOCs also together. Two things it advertises to this thing. And over here it says, okay, hey, you guys, if you want to go anytime to this one, if this is the TLOC. If this is the TLOC, if you want to go to Dubai, this is Dubai. Dubai is reachable via business internet also. It is reachable via MPLS also. And what is the actual path? Actual IP is this one. Internet, this is the IP address of the real IP of Dubai in the internet cloud, and this is the real IP of Dubai in the MPLS cloud. It does not advertise. This behavior is similar to like what? IBGP behavior of BGP. Like that. So TLOC stands for what? Transport locator. It is made up of what? 3 components. What are the 3 components of TLOC? System IP, the WAN service, that is the color, and encapsulation, and it will be encapsulation will be always IPsec, like that. So this is what it shows together. See here, IP, that IP means what? System IP, color, and encapsulation. How do we remember it? TLOC 3 components. How you'll remember it? You can remember it by like this. ICE. I means system IP, C means color, E means encapsulation. ICE. ICE baby. Okay. Any questions, guys?
No, from my side.
So
sir, your voice gone.
Sir, are you speaking?
hello.
Yes, sir.
Okay, I just unplugged my headset. I don't know something. If we have this network, there are 2 routers. Let's say router A and router B. If router A has network X, okay, and router B has, let's say, network Y. So if A is advertising network, network X, prefix X to B, what B will do? If one router advertises some prefix to another router, what the other router will do tomorrow. Today one router is advertising prefix to some other router, to its neighbor. What the neighbor will do?
Never do the same thing.
Okay, he also does this same thing. Let's say he also advertises network Y. So now both have received each other's network X and Y. Both know, both the routers know. After knowing what? After knowing what will happen next? What is the meaning? What is the meaning of this routing? Routing basically is what? A is telling B, hey B, if you have any packet tomorrow, if you get any packet meant for X, send it to me. That means from tomorrow somebody does ping X. If somebody does a ping X, B will immediately send the packets for destination X to whom? To A. That is the meaning of routing, no? Routing, one of the author very beautifully, the one of the author said routing is like a promise. A router is promising another router. He's telling hey my friend, this is my network and I promise, and I'm telling you tomorrow if you get any traffic, send it to me and I will ensure that I will forward your traffic to the destination. So when A says I know X, tomorrow B, if B gets any packet meant for destination X, it will forward, because B says no, A promised me X, so I have to forward the traffic to A. And then A, if it has X directly connected, it will send the packet to the segment. If it is not directly connected, maybe A learned X through via some other neighbor, it will forward the traffic further. But as far as B is concerned, B is believing A, no? A's promise. So same thing here also. This guy is basically, they're promising, like, okay, we are going to send the traffic to you, and what is the promise we are taking? It's not like simply next stop. Next stop would have been is okay, but they are also promise ensure that you'll always send the traffic via IP. Say I don't want any packet come without any security, without any encapsulation, without any encryption. No, if you don't agree to this, then we will not exchange the data. So in normal traditional routing, basically we are only the routers are only concerned with the forwarding the traffic. But in case of SD-WAN now, it's not only forwarding the data plane traffic, we want to ensure that the data plane traffic is forwarded securely, and that's the reason they are taking a promise from each other that okay, you are going to send this is my IP, you have to send the traffic to this IP, but which WAN service you are going to use. If you use this WAN service, and how you are going to send, you are going to encapsulate in IPsec, encapsulation. So that's the reason TLOC is very important. See, in a simple term, we can say TLOC is next stop, but it's not only like IP address, not like a loop back IP like that. It's basically along with the IP, it is also telling the other router that how it is reachable, through which WAN service it is reachable, and then at the same time how the traffic will be forwarded, like that. Because security is very important. Security, we can say, it is paramount in the SDN framework. Cannot send any data unsecured across a public or across a shared cloud. Okay, guys.
Yes, sir.
TLOC's clear, like that. So you'll never see the next stop IP address like that. Let us see now again in a CLI routing table format. Let us see all this thing, how it looks like. If I go to let us take DC1 only. Let's take DC1. Now if I do show IP route, I say show IP route. What happened? Did DC1, what has happened? I'm not able to reach DC1. Who is this? New York. Let us take New York is logout session. Okay, any router, any WAN edge. Let us say on do in New York. If I say show IP route, let us make it little full screen only. I say show me routes in say VPN 0, or let us take VPN 200 this time, not 0, VPN 200. So it is telling. So if you see now, it is telling basically New York is telling, okay, this is see, it has received this route through OMP 44.44 like that. It is received this route, and you see it is showing what IP, not the physical IP of the Dubai. It is showing what? The TLOC IP. Next stop is the TLOC IP. And how it is reachable? It is reachable via which service? MPLS. And how the traffic has to be sent? See, all together, three things together. TLOC IP, color, and IPsec together. These are three things together is called as what? TLOC. Transport locator. So every device will have a unique TLOC. No two device can have the same TLOC. The reason is what? It is a system IP. System IP has to be unique. Yeah, WAN service can be same, encapsulation can be same. So out of three components, two components are common, but the IP is unique. Every WAN edge will have a unique IP, and that's the reason every WAN edge will have unique TLOCs. Okay, guys. So they don't advertise the next stops. Yeah? So when they are advertising the routes to the vSmart, that time they are clearly telling, okay, yes, this I have vSmart, I'm giving you this route I have, but how this route will be reachable? It is not advertising its physical IP. It is advertising what? The system IP. Why? Because system IP can be reachable via multiple paths. Like in case of basically Dubai, New York, and data center, they have two WAN connections. So as long as one WAN connection is up, it will be. But if you take example of now LAVH1, now LAVH1 has only one connection. Since there is only one WAN connection, whenever this LAVH1 this internet connection will go down, LAVH1 will get isolated, and since it gets isolated, all the segments behind LAVH1 will also get isolated because no other alternative. And that is where now we have to bring, first of all, we have to bring that no, we want this segment to be reachable at all time, and now we have to configure LAVH2. Okay, so finally we bring redundancy to Los Angeles, that is branch 3. So let us go to LAVH2. LAVH2 have I integrated already in the vManage? In the vManage fabric, have we already integrated? I don't think so. We are integrated. We have integrated only 5 WAN devices, right? So no problem. Let us quickly go to LAVH2. Show run system. Nothing is there. Okay, good. Quit. I think I have created the script file already. Let us go here. LAVH2. This is the LAVH2 name. I will just keep it like that. System IP 10.1.1.152. That is good. Site ID will be this. Its IP route. Yes. This is the MPLS router IP address. Right now, see, now the question is actually in MPLS now, VH2 is going to have what now? Guys, VH2 originally will have what? As per the topology, as per the requirement, MPLS is going to, service provider is going to run what? BGP, correct? Yes or no? For MPLS service provider, what is the routing in VPN 0? Transport VPN. BGP, correct? Hello? Hello? Am I audible, guys? I cannot hear you.
Yes, sir. Yes.
You're there because I thought again audio went off. I don't know.
You will be buzzed if anything, like immediately.
So in MPLS, basically, what is the routing? BGP, right? We don't have default static routes. But now this is, now you take LA, if you take LA VH2, if I configure BGP from CLI itself, everything I do from CLI, then what is the fun? What is our requirement? The requirement is what? We want this LA VH2 to become online, become part of the fabric as quickly as possible, and then we'll push the configuration. Through templates, correct? So that's the reason you see I have put a default route here. This is right. This is the initial underlay. This is the initial underlay route. Like that. Please understand. Otherwise, later on, because there is no BGP, I have not configured, because I just want this device to come up quickly. First of all, underlay. So like how in internet. In case of internet scenario for all the other managers, here also I'm initially putting a default route to go anywhere. I'm telling, hey, LAVH2, you want to go anywhere, you have to go via this MPLS router. But actually later on will change. So this is just for initial, initial onboarding. So this looks good. Control A, Control C, minimize. I go to LAVH2. Paste, commit. Okay, let us do very quickly. 10.111.1.251. Let us ping. So it is able to ping its gateway. If it is able to ping gateway, let me ping the controllers. Yes. So once it has reachability to the controllers, what I can do now, I need to get the certificate. So I go in the shell, I'll do SCP admin @192.168.0.211. vmanage has the certificate from there, /home/admin folder. Name of the root certificate, root CA certificate is root CA.crt space destination, my local, continue, yes, password, certificate has file has been received, CRT file has been received. We need to install that. How we install? Request root certificate chain install path /home/admin rcamps certificate installed. Then finally I have to say request VH. I have to now register myself. Activate chassis. Chassis number. For that I need to go back to the devices menu. We have to select one of this thing. On top one is there available. Copy paste. Copy. Go to this guy. Paste. Space. Token number again. Come back here. Extend the column fully. Copy the token number correctly. Paste it here. Done. See, 5 minutes job basically. Maximum it takes to get a device part of the integrated in the family. Certificate installed. So now we have this VH2. Right now we have this thing too. Now we have to do the configuration. Now once it has come, now what we have to do? We'll go and configure what? Templates. Now you guys tell me, we have these templates here. In this template now, we have a template. If you see here, we have basically single WAN transport, basically device template inet. Can I put now LA2 in the same device template as LA1? Can I put LA2 in with LA1 in the same device template? No. Why? Because LA2 is having MPLS connection, whereas LA1 is basically different, right? Like that. inet is there. So what to do? We have to make a separate, we have to make a separate device template for LA2. So what I can do, can I make a copy from here? Yes, I can make a copy from here itself. We will say single WAN transport branches, and single WAN transport also we have basically, the second one is basically MPLS. Single WAN transport here also, because name is same, so I have to put here also MPLS, like that, device template. So I say single WAN transport MPLS. So we have made a copy now, but this copy will be exact copy of the inet. So we need to modify then this one. Okay, like that. So what I have to do now? It will require what? Single WAN transport MPLS. It will, if you see now, if we go and do the editing part, we'll see for the transport section. No, first we'll see system. Basically we have created our set, that is okay, like that. For VPN 0, it is telling VPN 0, this is the template it is going to use. VPN gigabit 0, it is going to use this template. Okay, it is going to use gigabit 0/0. Will this work for this LA2? Let us see the physical interface. Yeah, it is gigabit 0/2. Yes, this is good. It can use this interface template. But if you remember, if this is the interface gigabit 0/2, what is in this same template is used by all the other WAN edges for their internet WAN service. Gigabit 0/0 normally is used for what? Internet WAN service. And for internet WAN service, what is the color? What is the color they get? The color we are defined, the color we are defined is what? Business internet. But now this MPLS route, this LA2 is not having internet, it is MPLS basically. So I can't use this template. So we cancel this. We have to create what? A new feature template for this one. Because I can't use the same feature template. Where is gigabit 0/0? This template will make it for MPLS. So I make a copy of this guy. Copy. I'll just write basically, this will be basically MPLS type interface. Normally MPLS should have been gigabit 0/1 interface, like that. But here I'm using it like this. This is MPLS. So I make a, first of all, I make a copy. Whenever you create a copy, it always goes in the bottom. So this is where it comes. Now we will edit it, because that that color cannot be, we'll see now, the color will show, color will be business internet. So if I go to the tunnel features, and there you see it is showing business. No, I said no, this is not be business, it has to be MPLS. So this one change we have to do, you have to remember. So now this template is ready. VPN 0 template is already there. But VPN 0 basically, yes, VPN 0 basically we have what? A default route. Now does you tell me now, does the Dubai router, no, not the Dubai, the LA2, does LA2 requires a default route now through the template? No, because originally just for onboarding we created the default route and made it part of the fabric. But once it has become part of the fabric now, why it is taking time? Anytime like that it happens. Let us refresh. Let's see, refresh works. If refresh doesn't work, immediately best thing is what? Stop this switch. Start the switch again. So we have to understand that MPLS router, originally just for onboarding we put a default route, but after that, once it has been onboarded, once it has become integrated, now once we apply the template, in the template we should apply what? The BGP part. BGP configuration must be there. So let us go and check the MPLS router. In the MPLS router, is there already neighborship defined? Show run pipe section BGP. So if you see neighbor 10 dot, I have basically, there are two neighbors I have defined, LA1 and LA2. This is LA2, so basically is, we have to do this correction. Or on the IP address, see, because this IP address right now I have configured for LA2. Okay, this IP address I have configured for LA2, then I don't require this one basically. So, but did I configure the IP address? What is the IP address I configured for LA2? Show run VPN 0. 152. See, it is not matching. It is not matching this IP. If I take this one, 10.11.1.151, here it is telling it is 152. So either I remove this, so we have to do some correction. So we have to do on the MPLS router some correction. We go inside BGP router, BGP 10. No. Remove the wrong neighbor statements, and then basically I'll say correct this to 150. Oh, $152 only. This one I have to change it.
No, remove the no.
Removing. So neighbor 10.111.1.152 remote is. I can check reachability also. Do ping 10.111.1.152 IP. Yes, reachability is there. This is correct. So this correction has to be there. So we go to this template. Did we make the correction? It is no, it's not happened. We have to make this update. Plus, yeah. So now this template got corrected. Now this is the template we have to use for LA2. Then will it require routing? Yes, it will require routing. What is the routing now? LA2 will require BGP. So what we do, we go to the device template now. This is basically, where is the device template? This is the, where is it? This one right now, 0 devices. So we will go to this one, and now we say edit. I go to transport and VPN this thing section. Now the problem is what? Again, here also this VPN 0 feature template. In VPN 0 feature template, there is a default route. Now the default route is not needed because we want to add interfaces. We want to use this one. No, we will not say I want to use this one. I will say I want to use this interface. So this interface, and then basically I need to add what? BGP. Okay, I say BGP which I want to add. I'll say BGP this one I want to add. This is okay, but the problem is what? This VPN 0, this template basically is not good basically, because this VPN 0 template feature template has a default route. Default route is not it, or otherwise leave it. Let their default route also exist, but actually it should learn through BGP also. So what do you want me to do? Remove the default route and have only BGP, or keep it as it is?
We can create the new one.
So better is new. So again I need to cancel this. Again I go to this feature template. I'll go to VPN. Where is VPN 0 feature template? Okay, for this one, VPN 0 feature.
Sir, or we can create a greater administrative distance of this one default route.
No, but if you create that template is common for all the WAN edges, no other.
But other people are not using BGP, na?
No, BGP they're not using, but VPN 0 template is common for everybody, na?
Yes, yes.
Administrative distance, if I modify that, it will get applicable to everybody then.
Yes.
So that's the reason basically we have to see that, So best thing is what, make a copy separate, since anyhow. So basically this is for, MPLS, we can say feature template for MPLS. Make a copy where it has come now. This is the one. There is another, and there I will show you now. There is one more option there, if we want a, like maybe some places we want default route, some places we don't want the default route, like that also possible, na? It is like that. So if that is the requirement, na, if I go to this IPv6 route here, okay, if we go to this IPv6 route, if you see, if I make this, if I tick this box, see, do you see this option? Optional basically means what? It will prompt for every vantage, it will ask, you want this or you don't want. That is possible, one thing. But no, we don't, because then what will happen? Hundreds of WAN devices, it is going to ask me that question. We have to, then it will come in the value. You want this default route, okay. Otherwise, remove this default route. It is going to prompt me. No, so we are not going to do this. I'm going to just delete this default route. So now default route is not there. Update. So this template is good now. And now I think we are ready. We are ready to make this LA2 also we managed. So where is that? MPLS over here. I say edit.
But we removed the default route, but we didn't add BGP, no, sir, in routing.
BGP will include. Now I go to transport VPN section again. I say I don't want to use this one. I want to use this one because this one will be without default route, but at the same time there will be BGP routing which will provide reachability. So this will provide reachability to the LA2. From here the default route will, whatever was there already, it will get removed. And the interface also, this is not the interface, this is the interface I want to use, because the service is MPLS, the color is MPLS. Rest all remain same. Now what about service VPN? Yes, VPN, this one also will require, it will get service VPN 100 because it is copy, we made copy of LA1. So we'll do that later. Yes, right now let us first at least get the 0 side. So now the template is ready, device template MPLS is ready. Now we finally say attach the device, and this time I say I want to attach LA2. Where is LA2 now? This is the one. 10.1.111.152. See, with the IP I can make out 152 means the second vantage, and 111 basically means LA. Host name we can change because host name will make it in the template. So now we provide the values for the template. Okay. Oh, host name is not coming here because host name already it is telling here. Site ID 111, system IP 10 dot. It has to be, we'll select one of this and we'll correct it. 1.111.152. This will be the system IP. Same from here. Host name I will say basically this is, LA. We can keep it LA VH1-02. Then basically gigabit VPN 0 gigabit IP address. Gigabit IP address will be 10 dot 111.1 dot IP address will be 152/24. That is the IP address of this thing. Then MPLS neighbor IP will be 10. I have to just make it 111.1.1.251. And finally VPN gigabit, VPN 100 gigabit to IP. I don't know what is IP. I think it was 10 some IP. 10. This one will select, but it cannot be 151 because 151 belongs to LA1. So I make it 152. This is the LAN side, VPN 100 gigabit 0/2 interface. So I think I have provided all the information. There is a possibility of things going wrong. Suppose if it remove the default route first, then reachability will be gone. Then it will not be able to apply the BGP configuration. Actually, we should have applied the BGP template first. And once the BGP template is there, once neighborship is getting established, once the route is getting advertised, let us see this VH2. Show BGP neighbor established. Neighborship is established. Good. Oh, done. No issues. So luckily we got the configuration. Let us see the configuration now. Show run VPN 0. Interface IP encapsulation it got. Color it got. Allow services. All those things. Interface is up. And then if you see when I say show BGP routes, it is learning all the routes. 10 111 New York it is learning, data center it is learning, data center DC2 it is learning, Dubai it is learning, loopback, this is the loopback of the MPLS router, then it is also receiving this route, how to reach the controllers. And now if you see when I did when I did show run VPN 0, now you see in VPN 0 there is no default route visible. The default route has gone because we removed it now, because it does not require any default route. Now it has already become, BGP is already configured now straight away. We could have done this BGP also through CLI also, but then what is the fun of doing everything through CLI? Just with minimum configuration, get a device on board in the fabric. Once it is in the fabric, then you do whatever configuration, the full configuration through the templates. And now if we see devices, even it will show LAVH2 we managed, and it has a default this thing. Okay, but now the question is what we require here. You see here there is a router 11, there is a router 11 here, and I want to run here what OSPF here. So LAVH2 will require OSPF here, because this router LA1 router 11 has basically OSPF here running. It's not configured only. Let us quickly do this. Let's go to router 11 configuration. Loopback is there, IP address 192. Interface IP. No, this cannot be in a different subnet. IP has to be, this IP has to be 10.0. I don't know what was it. VPC.
Can you send us the updated configuration file actually?
This folder I will send it now.
Yeah. Anyway, you are doing it, because for us again it will take time.
But that is where the learning, some mistakes will be there, so you should be able to.
The problem is this one is not working, right? The simulator we take properly. We spend a lot of time here to get one device online. Actually, that is it. Anyway, thanks. Yes.
Okay, I'll share it now. So what was the subnet here? VPC. Let us go to VPC. I think I did not save, right, on VPC. Oh, we have to get the IP address from VH1. 10.0.111. So router 11 we have to make the IP 111.11, this IP, and then it has to advertise this one, plus there has to be one more network command 10.0. Area is good. Router 11 router 11 is up, interface is up, ready. So LA2, now LA2 needs to add. So what we do again, go back here now. So one final thing what we have to do, we have to go to the templates. We have to now say, we have to add what, for in case of LAVA2, it is not just directly connected, it's not connected to directly computer, it is connected behind what, to a router basically in that segment. So it has to run OSPF. So for VPN 100, do we have an OSPF template? Yes. For VPN 100, do we have an interface template? Yes. Is the interface template same? Is the interface same? Yes. Gigabit 0/2 for OSPF most of the time. Yes. So if you see data center also gigabit 0/2, VPN 100 is there. So the template which is used in data center can be used for LAVA2. So I go back here. We go to MPLS, edit, and we add now the service VPN now. We say service VPN. Service VPN already, this VPN 100 is there. Interface service VPN 100 interface template, it is telling already there. I have to add OSPF here now. VPN 100 OSPF, that's it. So area ID, if you remember, it is 0 there, and it says what is the interface name you want to use. Interface is basically gigabit 0/2. I specify. It already has that IP address. See here, VPN 100 gigabit 0/2 IP is already there, 152. Update, that's it. Once I do this, it should form adjacency with router 11. This router 11 should form OSPF neighborship with LA2. And once it forms neighborship with LA2, then router 11 will also have reachability to everywhere in with service VPN 100. It is telling success, but it has not formed neighborship. Why it has not formed neighborship? Show IP OSPF neighbor. No neighbor. Ping 10.0.111.152. Reachability is the right. Then why did not form neighborship? Router OSPF1 network 10, this one link advertised 10.0. What is IP? IP I gave wrong. See, it is 10.0.111.11, whereas here in the network command I configured a wrong IP. Network command was wrong. Now it should form adjacency with There you see in the file also 11. IP is not 1, it is 11. So save this. So I'll do one thing, whatever this files today we have configured, I'm saving the configuration. I'll share this updated folder with you guys. Okay.
Yes, sir. That will help.
But then what I will suggest, earlier also I shared the files, right? This folder I've shared already with you guys.
Yes.
Okay. Try to use that folder first. See that you encounter some troubles, some problems. Try to solve them. If you're not able to solve, then you refer to this configuration, corrected configuration. It's just a suggestion. It's all up to you how you want to work. Okay. Because if you do troubleshooting, it will be more learning experience will be there. If you don't encounter any problems, then no challenges means this becomes very easy. We come across challenges, that's the reason. So anyway, this is done now. And now finally, if we go to the fabric, let me go to router 11 itself. Let's see router 11. Can it now ping data center, custom data center ping 10.192.168.12.12, and there you see it is reachable. Can I do telnet to this server? Yes. Connection refused. Sorry. Why connection refused? Router 12. Router 11. Connection refused. Transport input none was there. You see, router 11 is able to access via telnet this server in data center. Router 11 can also access port 80. There you see it is accessing HTTP. Via HTTP also it is able to access router 11. 443 port HTTP secure. The see port 443 is also open. Show IP HTTP server history. So it is telling me like who connected to me. 10.0.111.11 on source port was this one, like that. Destination port was this is 80. Second connection came was from the same IP with a different random port number. How many bytes? What was the transaction between this? HTTP did not much and not transaction, but HTTP some incoming outgoing happened. I can see this. See. Can router 11 now access 192.168 Dubai 44.44. Yes. Candidate access 172.16.33.33 in New York. Yes. See. Why? Because now LA2 has the reachability to everywhere. So if I go back to again monitor network section, I select now LA2. I go to troubleshooting. I say simulate flows. It has only one VPN 100. Select the interface destination. I say show me how can I reach to Dubai, that is 44. Simulate. It says it can go through C because LA2 has only MPLS. It says only it can go to Dubai only via MPLS. It cannot go via internet. LA1 will show only internet, business internet color. Clear, guys? So now as of today, all the WAN edges have been integrated, and at the same time what we have basically, sorry. All the VPNs have been implemented. VPN 100, VPN 200 has been implemented, and all the locations are able to communicate with each other, and the data is going securely. The data is not going clear text. No communication now is happening in secured. Whenever the components are communicating with each other, that is through DTLS tunnels. Whenever the data plane traffic is coming, that is happening through IPsec tunnels. So not a single packet will go now insecure basically. So this complete thing is up as of now fully. All the branches now can go. But right now what is happening? VPN 100 users cannot access VPN 200. VPN 200 users cannot access VPN 100. Why? Because communication between two service VPN by default is not there. Same like between communication between two VRF is not there. Communication between two VLANs is not there. Same way here also the same thing. If we want now communication to happen between two VPNs, then we can do. That is possible, optional. That is what we'll see in later on in the labs. Same way right now how the traffic is flowing. Suppose this LA branch, if they want to go to Dubai, how the traffic is going to flow? Yes, guys, can let us quickly do this, and then we can wind up for the day. One question: if this VPC, if VPC is sending traffic to Dubai, okay, here is, let's say Dubai network is there here, because in this is VPN 100, that means he can access here. Let's say network X is here now. Is this, if VPC is sending traffic, how the traffic will go? It will go to where? How it will go? Because this guy has what? Gateway here, right? So it will forward the traffic to the LA1. Once the packets land on LA1, what LA1 will do? It will forward the traffic to the INET, because it has only INET cloud. So it will send the traffic like this. It goes here. And it will come back like that only. But this traffic, how it will go? Will it go like that clear text? No. It will go IPsec, correct, guys? Clear?
Yes, sir. Yes.
It will go IPsec.
Same thing. This PC, sorry, sir, sorry. I just want to ask you some kind of HSRP kind of thing we can do here?
HSRP we cannot do because this is
LAVH.
No, LAVH we can VRRP, yes, VRRP we can do because HSRP is proprietary, no?
Yes.
VRRP can be done, yes. SD1 supports VRRP. Yes. So if you want, like, LA1 and LA2 should do, should do VRRP, then that is also possible. Yes, why not? Like that. In fact, when we are going in the interface, if you remember, when we went in the interface feature template, one button is already there, VRRP, next to the tunnel. Like that. So VRRP is there, possible. Why not? Like that. If we have the time, we have 1 weekend to complete. Next weekend we have to complete those labs, those additional labs, manipulation labs, fine tuning labs, and all like that. So if we are left out with spare time, then if you want, we can do even that VRRP also. I can demonstrate, not an issue. But that we'll keep it in the last, provided we have the time. Or as I said, I don't mind having one extra session also with you guys, one extra weekend. It's up to you later on. Okay.
Yes, sir.
What about this one? What about suppose router 11 is sending traffic? How the traffic goes? Router 11 will send the traffic to LA2. Then LA2, what it will do? It will send the traffic via this MPLS cloud. It goes here to network X. This is how it goes. And it will also come back here. But again, how the traffic is going? Whether it is going through any WAN service, it is not going to go. It is going to go secured. IPsec. So any location wants to communicate with any other location, the traffic always goes what? Directly between those two locations, correct? LA and Dubai will communicate directly. LA and New York will communicate directly. LA and data center will communicate directly. Right? It will not go via. Nor this vSmart is coming in the path. Data plane, vSmart is not coming in the path. Please understand this. vSmart is not. The traffic is going straight away directly. Why? Because LAVH2 says that if it has to go to this network X144, it will show the cloud. Basically, it will show the T-lock. That is what we saw already on the T-lock basically. Six WAN edges it is showing. All the connections are showing. I go to network. Again, I say LAVH2. Simulate flows. Destination. If I say Dubai or data center, anything, it will show what? See, it says now it will take only always MPLS. But why it is showing now two paths? Because in the data center, there are two guys, DC1 and DC2, they are advertising the same destination. So two paths to go to the data center. Whereas for Dubai, there is only one path. So it shows only one path. So going and coming, it will take MPLS. And what is the default promise? The traffic will go IPsec. Packets will never go clear text, normal. Okay, guys. Any questions today? So everyone clear that OMP has to advertise which routes? Normally service VPN routes, but service VPN route, the next stop is what? Next stop is not the physical IP. The next stop is what? The system IP. But not only system IP is advertised, next stop, it is basically converted into what? A T-lock IP. And then the T-lock basically means what? System IP and the WAN service, that is color, and the encapsulation is also important. Like that. So you're not telling the device that, okay, just this is the next stop, to go to this destination, just send the packet. No, along to send that packet, you have to first agree that you will send the packets encapsulated in IPsec tunnel, then only you will forward the traffic like that. Then only you install the route. So it shows like that. So this is the destination. This is the TLOC. To go to this TLOC, this is the WAN service you are going to use, and how the traffic will be sent via IPsec encapsulation. So all that, most of the terms I have explained you guys now. So if no questions are there, we can wind up. If you have some queries, you are welcome to ask me whatever questions you want.
No, it's fine, sir.
Okay. Now I think this week I will see that I will allow only, please guys, don't practice together. Okay. Avoid practicing simultaneously, because then it will create problem for both of you like that. So best is what, announce in the group first. Let everyone know in the group that so and so is practicing, so that the other guys should not do the practice at the same time. In the meantime, because
Sir, you can post a message in WhatsApp so that the student who is absent, they also come to know.
that is what I will, in fact, I will send in the WhatsApp that message. But you guys also, whenever you like, if you want to practice, you announce first that okay, right now I'm starting my practice at this particular time. From just give some time frame that okay, from this time to this time you want to practice, so that everybody will come to know. Okay. Because I will set up one more VM basically. But to set up that VM, basically it will take time. Basically, it's not like if everything goes good, it will happen in 1 hour also. If it's not smooth, maybe it might take 10 hours also. So to get all the images and all installed properly, I need to basically install. So that's the reason. At least if some tomorrow, at least for tomorrow, basically guys, if you're practicing, announce in the group. I will also send the message in the WhatsApp group that don't practice simultaneously, practice one by one. Take your slot, basically morning, whatever time you want. You see that. So somebody else wants to practice, you should announce that okay, from maybe 12 noon I want to practice, 12 to 2, 12 to 3, whatever, 2 hours, 1 hour, 2 hours, 3 hours. I think you should not practice less than 2 hours minimum, because 1 hour will not be good enough like that, because you have to set up, start and all. So at least minimum practice, keep for yourself free for 2 hours during your busy work schedule, so that you can practice this simultaneously. Okay.
Yes, sir.
All right then. So that's it for the day, guys. Hope you enjoyed. Things are looking very nice now in the dashboard. And this
Labs are there still.
and this thing also, basically the simulate flow is also a very good feature. We can actually see how the traffic is flowing, how many paths are there. So that is a very good feature.
How many labs remaining for now?
I think basically I think 5 to 6 labs are there basically now. Normally, again, maybe with explanation all, basically it should not take basically one lab, basically 1 hour, 1.5. Maybe one or two labs, basically it takes more time. Otherwise, basically it should not take more than 1 hour. But what happens, sometimes something goes wrong, troubleshooting issues come, and I always like challenges to come so that we can resolve those issues and learn something new, basically, because we need to get geared up for the future, because in future if we come across some issues, basically some problems, then we must be able to troubleshoot them. If everything goes smoothly, then there is no basically no learning. Basically, challenges means learning. Okay, guys, see you next week, same time.
Yes, sir.